Good evening. This is Dr. David A. Padgett, and my goal for this evening is to prepare a master map that contains all students' data so that you can complete geographic information systems assignment through. So I'm going to share my screen. And here is the assignment. Data analysis using the North American hometown geography map. Again, if you need to create your own public account in ESRI, the steps are there. If you need any help with that, let me know. If you already have an account, you can go down and you can see what I'm going to produce now is going to look something like this. A map that has all of your cities on it. And so, I'm going to paste the link to that map here and probably going to drop it into the Dropbox also for easy access. Okay, so let's get started. I'm going to do this for you, this meaning build the map, so that you'll see the process. So the first thing that I did was notice I saved all of your spreadsheets. And the next task is to take the data from each individual spreadsheet and add it to this master spreadsheet. So here's the data here. And so let's just start off with the first data table. First, have to look at the data and make sure it is clean. So you notice that city population, fine, landmark, latitude, longitude. Longitude is a negative number. Very good. Now, as far as elevation, we don't want to have any characters in a numbered cell. So I'm going to take that little tick mark out. Let's see. I'm not going to get into whether or not these answers are correct right now. I'm not going to make any assumptions. I see some iffy. Once again, here we have another error. Okay, so no characters in a numbered cell. Okay. Smoky Mountains. Again, we have more characters in a numbered cell. Here, let's get all of that out of there. You know that we're dealing in miles. And now I'm going to save this spreadsheet. And now I'm going to copy the data from here into the master spreadsheet or the main spreadsheet. Make sure everything lines up. Perfect. And so now I'm going to go to File, Save As. Save that into the Spring. I'm going to call this Spring 2024. As I continue to build this spreadsheet. So I'm just going to take a look at a couple of these. And here's another spreadsheet. Good. City population, good. Memphis Pyramid, Bass Pro Shops, fine. Notice we have characters in the latitude, longitude cell. That's not going to work. Let's get these characters out of there. Only numbers in a number cell. But it's good. Longitude is a negative number in the Western Hemisphere. Let's get that tick mark out. Let's see, physical region, that's not exactly correct. We'll deal with that later. Subregion South, that's not exactly, but that's fine. Distance to major body of water. What city is this? This is Memphis. Obviously, I'm going to make the correction here. Normally, I wouldn't, but clearly, distance to the, oh, yeah, there's a way. We'll demonstrate that later. Distance to closest mountains, we'll just split that down the middle and say it's 175. Natural hazards, okay, plenty of those. I'm gonna save this here. And now I've cleaned the data up as much as I'm gonna clean it up. When we do the live demonstrations in class, I'm probably going to have you all examine your own data and look at some of the issues there. Um, okay, so there's record 2. And so now I'm going to go to the next section and let's see what we have there. So this might be let's see, Hampton, got Walk, Wisconsin, good, Riverwalk, good, good. Elevation, no. Curb and climate region looks so well, looks kind of okay. Sub-region, now we'll fix it. Okay, we've got characters in a number cell here. And whoa, okay, okay, okay. Like I said, we will deal with some of the data issues with the map when we do the live demonstration. Right now, I'm just trying to make sure that the database data is clean. Um, hmm. Wow, okay. Okay, so there's 3 there. All right, so I am going to pause the recording for a moment. And okay, so I paused the recording just so that I could build out the data table. Um, some of you all did a really good job as far as the latitude and longitude for the most part. Everybody had negative longitudes. We'll see when we produce the map how accurate the data are. One person rounded the latitude and longitude numbers off. Should not have done that. We'll talk about why that matters later on. I'm going to go in and format the cells to number, and I'm going to push the decimal placement to maybe 8 places behind the decimal, just so that we'll have uniform data. I'm going to save. Everything. Notice the data is clean here. No characters in the number cell. Some of your answers were kind of questionable, but we can deal with that later. Some of you all did follow instructions, and I can tell who actually watched the video and maybe who was just kind of winging it. And let me just correct that. See, I'm still finding some errors here. Let's correct that. No, I'm just gonna for aesthetic purposes, I'm just going to align this right alignment so it matches. So it looks like everything that we have. Let's see, there's a lot of data there. I'll leave it in there. All right, so now the next step is to convert this to a CSV file. So I'm going to go to File, Save As. Of course, I'm going to save it to my folder. I'm going to save this as a CSV comma delimited file. Save it, and we get all kinds of weird error messages. Just pop through them. So now this is saved as a CSV file. And next is we're going to go to ArcGIS Online. I already have my account open, map, and open up the map here. And I'm going to add layer, add layer from file, and choose from my device. And there is the CSV file. Open it up. Looks like everything looks good here. It's good there. And let's look at this now. So we have, I'm going to change the edit layer style and change the field to, let's change the full name first. And now you can see that we have everybody's, let's see, we have Nashville. We have 4 people, 5 people in Nashville. So we have Nashville. We do have, let's see, what's this? We have Greenville, South Carolina here. Huntsville, Alabama there. I believe we have Milwaukee, Wisconsin. So we have a pretty good coverage, in terms of where our cities are located. We've got Pensacola, Florida. We've got a pretty diverse group of cities here. Memphis, Tennessee there. And then we also have Denver, Colorado. Now, we want to change the base map to see the cities a lot easier. We can go to light gray canvas, and then we can clearly see the cities. But Denver's got the little dot over top of the name of the city there. We can clearly see our cities. What might be a little bit better is if we go to the edit layer style, and then we change the field to and we changed the name of the field to, let's say, we called it that hometown, city, and state, and that'll give us a better idea of which cities we have based upon the legend. And so if we pull the legend up here, then now we know exactly which cities we have, in case there was some confusion earlier. So we have Pensacola, Florida here, Milwaukee, Wisconsin there. Okay, so let's get into a little bit of how we might go about working through this assignment. So here we have, so first, going to give you the link to this map. Let's see, I have to save the map first of all. Save as, I'm gonna call this geography 1010 spring 2024 GIS 3. Oops, 3. I'm gonna add a tag, Tennessee State University. And another tag, GIS. Okay, save the map. So now the map is saved. And now that the map is saved, I'm going to share the map. Make sure the map is public. Here, save it. Okay. Update sharing here. All right. So now our map is saved, and presumably we're going to take this link here. And I'm going to take this link and I'm going to copy that into the Word document. So you should now be able to get to this map. I'm going to try something else also, just in case. I'm going to pause recording for a moment and try something and then come back. Okay, so what I did was I pulled the table into uh, the classic view for ArcGIS Online, which has a much better sharing option. So I'm going to go here, make this public. So, when you do this assignment, you might want to switch over to classic view, might make things a little bit easier. So I'm going to copy this link. Well, do this, do share, and copy this link also, and say, so both of these, I'm going to test these links myself. I trust the classic view link, but you can do the assignment with either the new or the older version of the software. Okay, so next it says the question is find the two cities on the map that have the greatest difference in terms of their physical geography and so on and so forth. Elevation that what if you wanted to find out which two cities have the greatest difference in elevation? Well, you simply go to content, go to change style, change the attribute to average elevation, and notice what happens. Notice that the symbology, the size of the symbols represents the elevation of each city. So notice you have a city here, Denver, Colorado, that has a very high elevation, well, relatively high, 5,280 feet above mean sea level. Conversely, we have Pensacola here that is only 102 feet above mean sea level. And so those two cities probably are going to have a lot of differences. Denver is very much inland. Pensacola is right on the coast. But there are other cities that you can look at in terms of comparing and contrasting. You might look at in terms of, let's look at Milwaukee. So Milwaukee, well, let's compare Greenville, South Carolina in terms of its land cover. So we change the base map and we look at imagery hybrid. Now we can maybe change this, maybe just back to the city, name of the city, hometown, city, and state, and hit done. And now we can look at what's happening. Let's look at Greenville, South Carolina. And we can look at very lots of vegetation around, very green. Conversely, we might take a look at some place, and probably it's pretty obvious that look at Denver. Look at Denver's vegetation compared to that of Greenville, South Carolina. Very different. Are those the two cities you want to compare? Let's look at Milwaukee, Wisconsin. So here's Milwaukee. And let's see what was the change the base map so I can, well, we can look at, well, obviously there's clearly a difference in terms of Milwaukee versus Denver. We have this large lake here, Lake Michigan. Denver, very little water in Denver, not a whole lot of it. It's clearly a much drier area. And look at the terrain. In terms of terrain, Denver, very mountainous here. Let's change our base map to terrain with labels. We can clearly see lots of mountains here. If we compare that to Pensacola, Florida, let's see, what were the closest mountains to Pensacola, Florida? Was 36 miles. Now, see, this is where we might have a problem in terms of an error. We'll have to correct that. So check the database. Okay, some of your classmates might not have accurate answers. Make sure that you look into that data, it's presumably correct. And we'll talk about it later. So let's look at some other parameters in terms of, let's see, we looked at, we got latitude and longitude. We can compare latitude and longitude. Where are these cities located? We can compare vegetation, bodies of water, so on and so forth. Then, of course, you describe how you use the map functions to get your information. So you might say, well, I showed that Pensacola, Florida's vegetation is very different from Denver's using the imagery hybrid base map. Now, I don't know where Rocky Mound is. I seriously doubt if that's a mountain. But I would say that if we're going to be more accurate about the mountain range, we can go to terrain with labels. And let's say it looks like maybe the safest would be the Appalachian Mountains. So we would go, well, how far away is that? We'll go to the measure tool and we'll change that to miles. Click on Pensacola, Florida, and we get to the southernmost Appalachian Mountains. Let's say it's about 250 miles or so, about 250 miles. As compared to Denver, Colorado, Denver, Colorado really isn't very far from the mountains at all. Let's see, we got 12 miles or so. So if we go to measure tool, let's see, miles from here to there, yeah, about 12 miles, perfect. So whoever did Denver got that correct. So you have a big difference there in terms of terrain, very mountainous, lots of mountains near Denver, not a whole lot of mountains anywhere near Pensacola, Florida. Distance from major bodies of water. And I emphasized major bodies of water. And so, yes, so, and like I said, you can pick any two cities to compare and contrast. It's pretty obvious. If you want to compare, if your hometown is Nashville and you want to compare that terrain to, say, Milwaukee, Wisconsin, that's fine. You don't necessarily have to find the two extremes. You might just want to compare your hometown to another city's physical geography. Okay, so next, let's look at the greatest differences in terms of population size and U.S. Subregions. So we can do the same thing. We'll go in here, we'll change this layer. Instead of saying hometown, city, and state, we'll change the city population. Let's see what we come up with here. So we have some big differences here. We have a city with 7 million people in it. Okay, again, let's see that. There's that is definitely a mistake. Okay, so check the data. If something seems strange, there's no way there's 7 million people in Nashville, Tennessee. Again, I asked you when you did the second GIS assignment to use the data sources listed. For example, I asked you to use the census to get population. Obviously, if you Googled it, you probably got a wrong answer. Okay, we're going to talk about that when we do the hands-on demonstrations. So we have an error there. I seriously doubt. Well, let's look at how we can correct the data. Let's go to the census site. Census site, and let's go to I want to make sure that I show you exactly what to do correctly. So I'm going to pause here. Okay, so in order to get population data, we want to go to the census site. Go to data and maps. And then we want to get to this site, Quick Facts. Go here, click on Quick Facts, type in the name of your city. So in this case, Nashville, Tennessee, Nashville, Davidson County, Tennessee, click there. Notice that the most recent population estimate is 683,662. Okay, so beware of that. Double check if something looks strange. Let's look at Milwaukee, Wisconsin. Milwaukee City, Wisconsin. Milwaukee, we have 563,305 as of the most recent data available from Milwaukee, Wisconsin. So be aware. Obviously, these two numbers for Milwaukee and Nashville are incorrect. The rest of them look okay. So we've got Pensacola, 54,000 or so. Greenville, South Carolina, 73,000. That looks about right. Memphis, 628,000. That looks about right. So be careful with the data before we make any estimation. You might want to zoom in, maybe look at this person's data, 683, 622, this person's data, 692. I don't know how. Anyway, clearly, we see that somehow we got 3 different numbers. So clearly people are not going to the census. What's this here? Also Nashville, 683, 622. That is a correct value. Okay, so again, we're gonna just be careful if some of these numbers are not correct. Luckily, you have for Nashville a couple of people who at least some people got the correct data, some people at least came close. I think the rest of the cities in terms of population, other than Milwaukee and that one Nashville number, Denver's fine. And so in this case, you might have to refer to the data rather than the symbology. Okay. So we can go to the textbook also. And so here's how to access the textbook. Now, if you do not have an electronic version of the textbook, just let me know. Scroll down, launch ebook. We want to go to chapter 12, which is North America. And we'll get into chapter 12. And we will simply go through the chapter page by page. And just go through the chapter page by page until we get to the map with US subregions. That's not it. That's not it. And so you'll see here subregions of North America, United States. And here is the US subregion map. So you'll find some differences. Some of your cities are in Appalachia. Some of them are in more than one region. Go into the textbook. What megalopolis? What are the characteristics of megalopolis? What are the characteristics of the manufacturing belt, if that's where your city is? What are the characteristics of Appalachia, if that's where your city happens to be? And so you can include that information in your essay. Also, we can go to the base map with imagery hybrid and compare, and so let's go back and change this to the city, hometown, city and state. Back again. And now we can look at how urbanized different places are. Notice Nashville, Tennessee has a lot of green. It's a very green city. Compare that, say, to Milwaukee, Wisconsin, perhaps. Milwaukee, Wisconsin, notice how much more built up this area is in Milwaukee. Not as much green space, a lot of concrete, maybe an older city. So there are a couple of other things that you can compare and contrast as you write your essay. Okay, so last but certainly not least is we want to compare our cities in terms of the climate. So we're going to go to climatecharts.net. You'll get a map and we can zoom in and let's look at, let's say, Milwaukee, Wisconsin. Get to the weather station from Milwaukee, Wisconsin. Click on that weather station. Click on create charts. And you'll scroll down and you'll notice you have a climate graph from Milwaukee, Wisconsin. And what you want to do is change this graph to a bar chart. So you want to have the your precipitation data in bar graph format. All you notice as you scroll through the map, you can see the different precipitation amounts in degrees. Remember, this is in degrees Celsius. I think we can switch this out, play with it. I know that there's a way that you can view this chart in imperial units, but you should get used to using Celsius units. But if you have any problems, you can simply okay, so there used to be a way to change these figures to imperial units, but because every country in the world except for the United States uses the metric system, now they are only given the data in the metric system. It's like a waste of time to use imperial units. So just get used to some simple, just convert the numbers if you're not familiar with these temperatures. You can simply use download something to convert degrees Celsius to Fahrenheit so that you'll know approximately what these temperatures are in degrees Fahrenheit. Simple conversion, 10 degrees Celsius is about 50 degrees Fahrenheit. 20 degrees Celsius is about 70 degrees Fahrenheit. And 30 degrees Celsius is about 85 degrees Fahrenheit. And of course, 0 degrees Celsius is 32 degrees Fahrenheit. In terms of precipitation, there are about 25 millimeters per inch. So there are about 25 millimeters per inch, just to give you. So for example, from this graph, if there were 100 millimeters of precipitation that on average fall in Milwaukee in June, then that's about 4 inches, right? Because 100 millimeters divided by 25 millimeters per inch is 4 inches, okay? So just keep that in mind. Okay, how do you get this table down? Just click on this PNG. There it is. There's your graph. Now, if you want to, let's save. I'm going to save this. Show you a little trick here. I'm going to save this. Well, I guess I can kind of crop it here. So you can crop it like this. I don't know what software you're using. Everybody's going to have something different. So I'm going to save this to my Spring. So this is Milwaukee, Wisconsin. I'm going to save that. And then I'm going to go into my, insert picture, and I'm going to go to Spring 2024. And where is it? Milwaukee, insert. So there's your Milwaukee graph. There's one, and then let's put the second one in here, shall we? And if you want, you can just get rid of the one that I put in there altogether, unless you need it as a guide. But you don't have to leave it in there. Okay, so what city do we want to, what city do we want to compare Milwaukee, Wisconsin to? What will it have a big difference in temperature? And like I said, you don't have to use the cities I pick. Matter of fact, I don't want you to. And so, well, I'm not going to show you. I just showed you how to get the first city map and graph in there, and then you can paste the second graph in. And then how do we compare these two climates? Well, you can look at the precipitation. Notice that Milwaukee, Wisconsin gets about 921 millimeters of precipitation, or close to 40 inches. Okay, or you convert that. Another city might get a lot more than that. Another city might get a lot less than that. Okay, what about forms of precipitation? We can go there. Some of this precipitation in Milwaukee is going to be snow. It's going to be frozen. Maybe the same you might say for Denver, but Pensacola, probably not. Okay. What about temperature? We can look at the mean temperature. What about the high temperature for the year for a city? So this red line, that's temperature. So the high temperature, average temperature for Milwaukee, Wisconsin is about 20 degrees Celsius, or about 70 degrees Fahrenheit, if you will. Compare that to another city. So you compare in terms of precipitation. You can compare them in terms of temperature. You can compare them in terms of a lot of things. Which month? Where is the most rain occurring in different cities? In some cities, like in Milwaukee, clearly it's the summer. Now that's not a seasonal pattern. What's the difference between the highest and the lowest temperature experienced during the year? And remember, when you write this essay, I want numbers. I don't want to see higher, lower, wetter, drier. You'll say this city has X amount of precipitation, next city has less, something else. Also, we want to look at the Köppen climate regions for each city and compare those. The Köppen climate regions are on this map. And so notice that here we have some cities are in this yellow color area symbol. Those are subtropical rainy regions. Or you have continental climates here to the north. Some places might be in the B climate regions, and so on and so forth. And so compare the characteristics of those climate regions, one to another, that are described here in this chapter. And I believe I also gave you an alternative map that came along with GIS assignment 2. Okay, so there you have it. You have your instructions, you have the master map to work with. Or I don't want to call it the master map. You have the cumulative class map to work with. I've shown you a few ways to navigate and get information to write your essays. If you have any questions, please let me know. Okay, so again, we'll be writing 3 detailed essays, follow the instructions. If you have a question, please ask. Don't just stay stuck. And don't ask your classmates, ask me. Like I said, you can text me 24 hours, 7 days a week. And I would suggest that you begin on this project early. So again, this is Dr. David A. Padgett, demonstration video for GIS Assignment 3 for World Regional Geography.